All right, a very good day to you, students of the senior math Olympiad category. So I'm going to be introducing you guys to one of the competitions that we started last year. And as you can see it on the screen, so the name of the competition is the World Mathematics Team Championship. So now for this year, the country that is going to be hosting this competition is Qatar. So which simply means that for those of us who are interested, we're going to be having some series of training. So the training will continue till the day that we will take the mock test. So it is those participants that do so well in that test that will be eventually shortlisted to go for the physical event November 27. So you can see the date there. The date of the competition is the 27th of November to 2nd of December. And the location is in Doha, Qatar. You can see everything there, arrival and all that. Now, we are going to be having 3 levels. So the first level is the junior level for those participants born on or after 2012. So you have to check against your age to know which level you fall into. Then we have the intermediate level. The intermediate level is for participants that are born on or after 2009. And I think most of us in the senior math Olympiad fall into the intermediate level and the advanced level. So for the advanced level, is for participants who are not high school graduates and who were born on or after 2006. So younger participants may also participate at a higher level. So that is the structure of the division for the group. Now, like I told you before this competition, they are going to send our school the kind of a preparatory exam towards this competition. Last year, some students partook in the preparatory exam. Some students from SHS 2, some students from year 13. I can still remember one from year 12, and some other junior student from year 7. Yeah, so they participated last year, but unfortunately, we couldn't make it to the physical event because it was very close. But the essence of we starting this training now is so that we can begin telling our parents. I'm going to share with you guys the costs for the, what they call it now, the traveling. So just hold on a minute. So I will share that, I think, in another video, not for today. I'll just give you the general information about the structure of the competition. Now, what are the awards for this competition? So as you can see, this competition is divided into, it's a very, very interesting and organized competition. There are some aspects of this competition that is different from the normal competitions you have been attending. Because in this competition, there is going to be a team round. So that team round, there will be an award for the top 3 teams. And remember, mind you, this competition is an international competition in which other countries are coming. So you from Ghana, you are representing Ghana as a country. So it's not just going for any competition. You're actually going to represent Ghana as a country. So there is an award for the top 3 team for the team round. There's also an award for the top 30%. There's a plaque for each team members and certificate. For the top 3 team, there's a special plaque for each team members and certificate. Then top 70, there is participate certification. certificate of participation for each team. Now, for the individual rounds, the individual round is the rounds whereby you'll be given a problem to solve by yourself. Okay, so we'll go into that later on. I'm just trying to give you guys the structure of the competition. So individual rounds, you'll be giving some individual problems to solve on your own. But for the team round, you will work with a team of students in solving a problem. You can see the various awards for the individual rounds. You have top 4 students will get a scholarship, 10%, top 10% will get a gold medal, top 20 silver, top 30 bronze medal, top 20% participates, certificate of participation and merit certificate. And then we have the relay round. For the relay round, you guys know the relay race. Those of you that have participated in athletics competition. So there is a kind of similar, it's kind of similar to the way athletics competition runs, in the sense that you have to solve a problem and then you pass the solution to the problem to your colleagues in the same relay team. So the colleagues will use the solution to work on this or our own problem. So it's a very, very interesting, and very nice competition. So that is for the relay round. So for relay round also, the team that has the highest total relay round score receive a scholarship for the entire team. So that is for that. So participants, team formation, a team can participate as a country. So we are looking at for those of us that probably do so well, because we conduct the first preparatory exam for you guys. So we are going to pick, we'll decide on how many students we are going to pick from Galaxy International School. I don't know of other school yet, but maybe as time goes on, bring in other schools on board so that we will go as a country to represent Ghana. So you can participate as a country, as a region, like Greater Accra region, or as a city, in this place where we are, or as an educational institution. So we can go as Galaxy International School or go as representing Ghana. So that is how this format is. A team member, each team consists of 6 students plus 1 team leader. So it simply means that by the time we start organizing this competition, we will now form, depending on the number of teams that we want to have, we'll have a team members, which consists of 6 students and a team leader. So please kindly pass this information to as many students in your class that you feel will be interested in participating in this competition. Let them know that there are a lot of benefits in participating in International Olympiad. It's just so much. Scoring rules. Okay, so I'm just going to skip this ones. So this will give you materials so you can actually go through them if you want to know more about the competition. The online registration starts 1st of August till 31st of October. So within that period, we'll be communicated and we will continue our training. And this training is actually going to be more like multifaceted, in the sense that we are also writing American Maths Competition, AMC, around November. So I want to believe that we should have time for that one also, because that one too is very important, because that is the road that leads to the International Mathematics Olympiad, which usually is written in all countries. In fact, that is a very, very prestigious competition. So trust me, whatever experience that you acquire from this training will help you in other maths competition. And beyond that, it's going to also help you in your career. Okay, so without much waste of time, I've delved through basically most of what we need to talk about this competition. So when next you have a lesson, I'll talk about the prices and everything, the costing, the air ticket. So you begin discussing with your parents so that they can be aware of the competition. And in case you're interested, you can join this class and we can start, having our training. So for today's class, we are going to be looking at the last year question, individual round 1. As you can see, the question takes 20 minutes question, and each 2 points for correct answer, half when you leave it blank, 0 for incorrect. So let's look at the first question. The first question says, in a repeating decimal number. So what do they mean by repeating decimal? So if you see from the screen, let me pick my pen. So when you see something like this on the screen, 1.725, so you can see 1.725, 1, 2, 0, 2, 3. And then you now see this bar on top, starting from 5 to 3. So it's simply telling you that this decimal is repeated. So that means from 5, 1, 2, 0, 2, 3, then the decimal continues. So if you want to write the complete form of this decimal, so you repeat this number. So you start from 5, 1, 2, 0, 0, 2, 3, okay? And then you continue repeating it like that. 5, 1, 2, 0, 2, 3. So it goes on forever without end. Okay, so that is what they mean. So in a repeating decimal number, 1.7251203, if we only keep the first 2023 digits of this number, including the unit digit 1, then how many 2s are in the new number? Now, to solve this question, you need to look at the way the numbers are being repeated. So in a repeating decimal number, if we only keep the first 2023 digits for this number, that means that if you start the first digit of this number, if we only keep the first 2023 digits for this number, including the unit digit 1, so telling you that this first number is also included. So that means if you count all the numbers, the way they are now, if you count the numbers 1, so the first number 1 is at position 1, 7 is at position 2, 2 is at position 3. Hope you can see my what I'm writing. 5 is at position 4. This one here is at position 5. So if you go on like that up to 2003, up to 2023, sorry. So up to 2023, if you continue, if you keep all the record of all the digits, first 2023 digits for this number, then how many 2s are in this number? So that means, first of all, you need to look at how the 2s are being, how many 2s do you have in this, the first few numbers you have before you start repeating. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 numbers in this, the way it is written originally, before it starts repeating. Now, out of that 9 numbers, how many times do we have 2s? So if we count, if we look at it, 2 appears here. Let me use a different color so that you can see it very well. So 2 appears here. The first time 2 appears in the 3rd position. So that's 1. The next time 2 appears in the 6th position, you can see there, that is 2. And the next time 2 appears, which is actually the last time, is at this point, which is 3. So it means that when you start from 9, obviously after you count 9 digits, the next amount of digits you keep counting is going to be from the number 512023. So let me use a different place for that to make it clear to we all. So now the digit is 1.7251. So I'm going back now. 7251. 1.7251 2023. 2023, right? So this is in the first position, second position, third, fourth, fifth, sixth, seventh, eighth, and ninth. So what I'm saying is that after the first 9 digits, the next digit is repeated from 512023. So let's look at that. So the next number is repeated from 5, 1, 2, 0, 2, 3. So how many numbers do we have? Let's count. So let me count. Let me use this to count. So the next number is 10 at the 10th position. So this one is 11th. This is at the 12th, 13, 14, and 15 position, right? So it's more like adding 6 digits number after the first 9 digits, right? So that is what you keep doing. So it's more like you started with a 9 digit number, then you add 6, you keep adding 6, you keep adding 6, up till you have to get 2023. Now each time for the first 9 digits, so let's go up. Sorry, let me use, so for the first, I'm trying to move this here. It's not going on. Okay, let me select. Okay, so it's going up now. Now for the first number, let me use a different color. Let's use 9. When for the first digit, when it was 9, we have how many 2? We have 2 appear. We counted it now 3 times, right? Good. So 2 appears 3 times. Now when it is now 6, so this is when it is 6 from here to here. How many times 2 appear? It's only 1 times, as you can see, just these 2. So when it is the next 6, 2 appear 1 times. So which means if the number keeps repeating, 2 will be appearing 1 times, 1 times. I hope you get that, up to the last 6, or whatever number that eventually got 2003. But we are not sure if we continue like that. Is good because the last number here, the last number, if it doesn't end actually, but if let's assume it ends at the last number, it's always going to end at the number in the it's always going to end with the digit 3, which is initially at the 9th position, now at the 15th position. But we know it doesn't end, so it just keeps. So now we are now going to ask ourselves that if we add 9 plus 6 plus 6 plus 6 plus 6, and we continue, at what point are we going to reach and get 2003? So I think we just need to do some arithmetic here. Now the arithmetic we need to do is this. So since 6 is repeating itself, so it means that 9 plus, how many times will 6 occur? Of course, 6 is now going to occur a particular number of times, which you don't know. So let's say the number of times is x. So let the number of times be x, or let the number of times this occur be x. Let me write it properly so we can see it now. So let the number of times 6. When I mean 6, all the 6 digits we are adding, you understand? So let the number of times 6 occurs be x. So you understand what I mean by that? That is, if you keep adding 9 plus 6 plus 6 plus 6 plus 6 plus 6, definitely you add it up to a point. Okay, it definitely doesn't mean that you if you keep adding it, by the time you add the last 6, it will be 2023. It may not even be up to 6. So this calculation will help us to know whether it's going to be up to 6 or not. So let's check, because we need to keep track of how many 6 we have, because the 6 is producing every time we add 6 digits. 1, 2 is being produced. Okay, we cannot have 9 digits again because that's the initial number we have. So 9 plus 6 times x, since it's adding 6 plus 6, that's 2 6. 6 plus 6 again, that's 3 6. So 6 times x, or multiples of 6, must be equal to, or is equals to, 2023. So now let's find the value of x. So we are hoping that x is going to be an integer, that is a whole number. If not, then that will give us an information. That means that will give us an information of the last number that actually ended. So let's take 9 to the other side. So that gives you 6x. Sorry. So that gives you 6x. So that therefore 6x will be equals to 2023 minus 9, which that's going to be 13 minus 9 is 4. So that should be 2014, right? So now, we now have that 6x. So we now have that 6x is equals to 2014. So let's divide both sides by 6. So dividing both sides by 6. So we have x to be equals to, now 2 can go in both of them. So 2 in 6, that's 3. 2 in 2, 1. 2 in 0, 0. 2 in 1, 0. 2 in 4, 14. That's 7. So now we have 3 divided by 1007, which we know is not divisible. So it means that it's the last. We did not the last number is not 3, or let's not say it's not 3. It's just telling us that when we added the number to give us 2023, it was not the last 6-digit number that we added. It was fewer than that. That's what it's telling us now. So now let's divide. So 3 in 10, that is 3. Remainder 1. 3 in 10 again, that's 3. Remainder 1. 3 in 17, that's 3 times 5 is 15. 3 times 6 is 18. So that's 5. 3 times 5 is 15. 17 minus 5, 2. So remainder 2. So that simply tells us that, yes, remainder 2. So we can write it as 335 2/3. Okay, 2/3. That's what we have. So it simply means that the total number of times 6 occur is 335. Now, remainder what? Since we're adding 6, 6, 6, so it means that what was left is not up to 6. It's just 2/3 of 6. So 2/3 of 6 is what? Let's check that. 3 here 1, 3 here 2. So 2/3 of 6 is 4. So it means that the last 4 digits that was added to the number that gave us, that now make it to the 2023 digits. So now remember we are counting how many 2s are there, right? So first of all, we observe that when the first 9 digits has 3 twos. So 3 plus the, so we keep adding 6, 6, 6, 6, and we found out that there are 335 6 digits that kept on repeating. And since each of the 6 digits that we add produces 1, 2, so it means that we'll have 300 and, so it means that we have 335 twos, okay? And then we now have 4 digits left that we added. So let's go back to the 4 digits and see if there's any 2 in that 4 digits. Remember, the digits are 6, 1, 2. So this is how we count it. 1, 2, sorry. 1. So this is the first digit, second digit, third, fourth, 6. So let me count it again. This is the first. So this is 1, 2, 3, 4. What am I counting? Hold on, I missed my count too. 5, 1, 2, 0. Okay, okay, I see the mistake now. I've made a mistake. Hold on. Let's go back again. I think I've seen my mistake. 5, 1, 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay. So, okay, I think my mistake was here. I'm supposed to have, so I'm supposed to have 5, 1, 2. Yeah, 5, 1, 2, 0, 2, 3. Okay, so I've seen my mistake. So I'm trying to correct myself now. So let's do the correction. So this is the first number, second, third, fourth, fifth, and sixth. Okay, so if that's the case, that means we have 2 twos, not 1, 2. So I've corrected that. So we are going to implement what we just corrected. So let's implement that. So now it means that the 335 6 that was produced, we produce 2 twos. So we have to first multiply this by 2 before we add it to 3. So let's move on. Plus, so we now go to, so we now have addition of 4 digit numbers. So remember, the 4 digit numbers start from 5, 1, 5, 1, 2, 0. So from this 4 digit number, we have 2 appearing only one. So it means the last digit number, the last the 2023, 2000 and 2023 digits was a 0, right? Good. And we just have 2 appearing once. So now we go to our calculation, almost done. So we now add 1, which is the last, because this 4 will produce only 1, 2. So let's do our calculation. So 3 plus, let's multiply. 2 times 5 is 10, 0 carry 1. 2 times 3 is 6, 6 plus 1, 7. 2 times 3, that's 6, plus 1. So 3 plus 4 is, 3 plus 1 is 4, 670 plus 4, that's 670. So let's go back to the question. So the answer is D. Okay? So the answer is D. How many twos are in this new number? We have 274 twos. So if you want us to check the solution, we are free. You can check the solution. So I have my solution. I think, let me see. Okay, the solution is not here. I've not uploaded it. So let me upload the solution so that you can actually see that we're on track. So this is where I'm solving my question. So let me use this place for solution. So I will add the solution to this problem. Intermediate training, individual solution. just for you to see that what we're on track. Okay. So question 1. So you can see there. So you can see it's the same logic we use, even though they did theirs differently. Okay. So it doesn't matter anyhow they do it. But we got the same, got 674. So I believe we understand the distance. Okay. So it's usually wise to solve the question before the next question. So now let's take the second solution. So let's take the second solution. Oh, Salom, we'll start, we started the training and it's just 1 hour training. So exam starts next week. So we're not going to be having the training during the exam, but we just want to start something this week, okay? So we are ending the training this week to begin after the end of the exam. Okay. So the second question, question 2. This is a 1 hour session, so we just have a few minutes more. I think I can just solve 2 problems for now, for today. So question 2 says, when M and N are natural numbers that take on values greater than 1, which of the following 4 expressions cannot take on prime value for any M and N? So we can see the values here. So we have option 1, option 2, option 3, option 4. So for we to answer this question, we need to understand what a prime is. A prime is a number that we know what a prime is. Any number that can only be divisible by itself and 1 is called a prime. So that means that for any value, so which of the following 4 expressions cannot take on prime for any M and N? That is, for any natural number. Natural numbers are positive integers, like 1, 2, 3, 4, and so on and so forth. So it's telling that for any value that you want to pick for M and N, which of them will not be a prime? So that means that out of this option, it's either you have 2 of them, because looking at the option, you have 2 options not being a prime, and you have only 1 option being a prime. So that means you have to look at the option carefully. And how do you determine if any of them will be a prime or not? So if a number, if the expression can be factored, for example, if I have an expression, let's look at this. So if I have an expression like this, and let's say you have an expression like this, 2m plus mn. Okay, so now 2m plus mn, I can factor it because m is common, right? So if I bring out the common term, then I'll be left with 2 plus n. Now, since m and n are natural numbers, so they can take in any value, not necessarily 1. So for example, if my m is 2 and my n is, let's say, 3, then 2m plus n will be 2 times m, that's 2 times 2, that's 4 plus mn, 2 times 3, that's 6, which is 10. Or if you use the factor, m is 2, using the factored form, times 2 plus 3, that's 5. So it simply means, because any prime numbers, any number that is a prime number cannot be factored. Isn't it? Because if a prime number can be factored, then it's no longer prime because it shows that it can be divisible, just like this one we have seen. So that means to solve this question, I will look for the ones in this option that cannot be factored. So those ones that cannot be factored will be those ones that will be prime. The ones that can be factored will be those ones that cannot be. So I will take the first option. So let's take the first option, that is n into bracket n plus 1 plus n. Apart from the fact that we want to use factoring properties, we can also use the property of even numbers and odd numbers. So I'm going to explain that next. So we all know that if a number is even, then it can be divisible by 2. And there is no prime number that is even except 2. Other prime numbers are odd numbers. Because if we have a prime number greater than 2 and it's prime, then that number will not be a prime number because 2 will divide it. And since the definition of a prime means a number that only 1 and itself, it can only be divisible by 1 and itself. So it means that the only even prime number we have is 2. So all other prime numbers we have, they are odd numbers. Now, looking at the way the expressions have been arranged, you see that some of parts of the options is a product of 2 terms. Some are sum of 2 terms, product of 2 terms. So they are arranged in so many ways. Some are even powers of a particular number in a base. Like option 3, we have n into bracket n plus 1 plus 2 raised by n. So this can give us a whole lot of ideas to know which number is going to be prime or which is not going to be prime. So now that we have this information, remember, first of all, we try to see if we can use our factoring trick to see if the number can be factored. Factoring trick. Next, we use what we call the even number or odd numbers. Usually, I think they call it parity. Okay, so parity check means to check if it's even or prime, or sorry, odd numbers. Now, because this expression involves product and sum, you know what I mean by product and sum. Like option 1, you have n times n plus 1 plus n. So we need to explore how even numbers evolve. For example, if I add 2 odd numbers, I'm going to get an even number, right? So the sum of 2 odd numbers is always even. You can actually prove that by example. You can add 3 plus 5, you get 8. Let's take another odd number. 9 plus 7, get 16. So there is no time you add and 2 odd number that it will ever give you an odd number. So that's one property. Then we know that sum of 2 even numbers will give you even. So obviously you can also prove this by example. Although proving by example is not the general way to prove, but we are not, this is an objective test, so we are not really concerned about proving anything. 6 plus 10, that's 16. So generally, sum of 2 even numbers is always even. That's another property that we want to explore. Then when you add an odd number plus an even number, you get an odd number. You can also check that 3 plus 2 gives you 5, right? 9 plus 8 gives you 17. So whenever you add an odd number and an even number, it will never give you an even number. It will always give you an odd. So that's another thing that we know. Also, if you add an even number plus an odd number, it also gives you odd. So it doesn't really matter. The order doesn't really matter. Now let's go to multiplication. If you multiply 2 odd numbers, you will get an odd number. So you can also check that 3 times 5, blah, 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 blah. Then if you multiply 2 even numbers, you also get an even number, right? So you can check that again. And if you multiply an odd number by an even number, 3 times 2, 6, 3 times 10, 30, so you get an even number. So these are properties that will help us in solving this question, because what we need to check is, one, is this number factorizable? If we cannot use factoring to, then we'll try to use a parity check to check if it's an even number or odd number. So I think these are some of the basic ways to handle this problem. So now let's take, so let's start with the first option, which is n into brackets n plus 1 plus m. So I think I will use a different, now I can still use this place. So I'm writing the first one, n into bracket n plus 1 plus m. Now you'll be wondering, what are we going to check? So since m and n are natural numbers, it is sensible for we to assume when n is odd. So these are the cases we want to consider. So I'm going to write it here. So cases we want to consider for m and n. So let me put it this way. This table is for m. This side is for m. This side is for n. So we'll consider when m is even, odd, even, odd. So which means, so how is this table going to be? So this first case is both are even. Second case is m is odd, n is even. Third case, the reverse. M is even, n is odd. Then the last case, both of them are odd. So we have 4 cases we want to check. I believe you understand the case work. So let's start with the first case, when both of them are even. So when both of them are even, let's start with the product. So this is going to be, so remember n is even now, even number. So this is even number. Now this is even number plus odd number. So if you go up, you notice that we said when you add an even number and an odd number, you get an odd number. So I'll be using O to represent odd. Or sorry, I'll use plus. Now, one funny thing about this even number and odd number is that if you use the sign of algebra sign, for example, let's say you replace your odd number with plus. I want to show you guys something. And you replace your even number with negative. Let's see what happens. Would this be a good way? Okay, it works for multiplication. So, does it work for multiplication? No. Let's see. Okay. No, it doesn't really work for multiplication. Let's see. Let me think again. Okay, so let's leave that alone. So I think the idea, I thought it's going to work out, but it doesn't really work. So now, so n is odd. So let's just say this is odd. O times, now odd number, sorry, n is even. So n is even, let's call that E, multiplied by n is even. Now you're adding even plus 1. 1 is odd number. So odd plus even or even plus odd will give you what? Odd. So this is going to be odd. That's the product. M plus 1 is going to be odd. Plus M is what? Even also. So let's multiply this first. Even times odd. Even times odd is even. So this is going to be even. And even plus even is even. So when both are even, the expression is even. And since it's even, it can't be a prime because 2 will divide it. So that is not, it can't give you a prime. So we've gotten 1. So let's move on. Since they say for all values, so we must check all the cases we are looking at. So we've checked the first case. check the first case. So let's move on to the next case. So the next case, the second case is n is even and m is odd. So m is odd, so I call this O. N is even. N is still even, but that one is odd now. So even plus odd will give you odd. Even times odd. Even times odd will give you, you can go through the table again if you like. So even times odd will give you even, right? From what you can see. So this is going to be even. An even number plus odd number will give you, even number plus odd number will give you odd number. So in the second case, you can get an odd number. And when you get an odd number, there's likely that you might get a prime number. We are not so sure, but it's likely that you can get a prime number. Okay, so, and the reason why the first case, we got an even number. And remember, we are using the value of m and n not to be 1. We just assume it. So if we do that, you can try it. This is 1 plus 1. This is already 2. 2 times 1 is 2. 2 plus 1 is 3. So when both of this, we can't even use 1. So once you use from 2, you won't even get 2. So what I'm trying to emphasize that is that even when we got an even number for the first case, that even number cannot be 2, because if both n and m are even, then they have to start from 2. So, and the answer will be, if the answer gives us an even number, it's definitely going to be bigger than 2. So now, second case, we got an odd number. So that tells us that there is possibility for the expression to be a prime number, because all prime numbers beyond 2 are always odd numbers. So let's go to case 3. So for case 3, we have odd and even. So this is odd. Odd plus even. Odd plus odd, sorry. Odd plus odd give you what? Even, right? Times even. Plus odd and even, that's what we are looking at now. Odd times even is even. Even plus even, even. So third case will give you an even number, so it can't be a prime. And then let's check the last case, case 4, odd, odd. So n is odd. Odd plus odd is odd plus odd, that's even, plus odd number. Odd times even is even. Even plus odd is odd. So now we realize that case 2 and case 4 both give us odd number. So that tells you that there is a possibility for the number to be, that expression to be a prime. Okay, can give you something like 3 and all that. So with that in mind, we'll go back to the question. So when m and n are natural numbers that take on values greater than 1, so even what we are using even greater than 1, that's what we need to know. Which of the following 4 expressions cannot take on prime values for any? So automatically, 1 is not looking like it's going to be 1 because of what we just saw now. Okay, and if you want to confirm, you can try and check a case where you have a prime number. Let's see if we can get a prime number. So if you can do that, you settle the argument once and for all. So now, when n is even and m is odd, so let's just check. Let's check this. So n is 2, m is 3. Let's check. So this will give you 2 times 3, 5. No, 2 times 3. Yeah, 2 times 3, that's 6. 6 plus 3. 9. Okay, let's not do that. Let's do 3, 3. 3 times 4, 12. 12 plus 3, 5. 15. It's also not prime. So if you continue like that, it's possible you're going to get a prime number. So what the best thing to do is just for you to go around and test other cases, right? Because like I said, this is an objective question, 20 minutes. So you want to be fast as much as you can. Of course, this is just a training to train you guys, but you have to be fast at a very fast pace. So I can just move on, okay, to the next, to check my next value, which is n into bracket n plus 1 plus m squared. So let's check that. Let's quickly check that. N. So we have n into bracket n plus 1 plus m squared. Okay. Let me check if I'm correct with that. Yeah, so that's for that. So let's quickly check that. Remember, we are checking against 4 cases. So this time around, I'll just try and do it in my head to make it faster. So now n is even. So n is even. Both of them are even. So even plus 1, even plus odd, that will give you odd. Odd times even. So odd times even will give you even. Plus even square is even. So first we give you even. So case 1 is out. Let's check case 2. Even odd. So we have even plus. So since we are still using even, so this will give you even. So only check to make it easier. Only check the case when m is odd. So m is odd. M square is going to odd square of an odd number will give m. An even number plus odd number is definitely going to be odd number. So again, that one has given us odd numbers. So case 3, let's check is true. So I think once we check a particular case, we are getting odd number. So it shows that there's possibility that it will give us a prime. So we can safely move on to check the ones that we know that for sure it will never give us a prime. Okay, we are not saying conclusively that n into bracket n plus 1 plus m squared. Because there's a case whereby it gives us an odd number, that odd number will always be a prime number. But we can actually try some cases, and by example, if you can show one case, then we actually do. But then, because we've gotten an odd number, so we can just move on to the next one, which is n into bracket n plus 1 plus 2 raised by n. So let's try that case. So for that case, is n into bracket n plus 1 plus, I think, 2 raised to the power of m. If you observe, you discover that we always have n into n plus 1 plus m. The next one was plus m squared. This one is 1 plus 2 raised to the power of m. So for this one thing to note is that in this case simplifies things for us, because 2 raised to the power of anything. So whether m is odd or even, 2 raised to the power of m will always give you an even. So this case is kind of simplified for us. Simplified means that's giving us that irrespective of what m is, this is always going to be even. So we just now need to try 2 cases for this one. So the first case is when n is even and when n is what? Odd. So when n is even plus even will give you even. When n is odd plus even will give you odd. So in this case, we still get an odd number. So it's possible we have a prime. So I'll move to the last one, 3 raised to the power n, which is option 4.
So for option 4, we have 3 raised by m there. So let's go. Okay, again, this is not a conclusive test. So let's not conclude yet. We're just trying to see what is possible. So 3 raised by m, this case is also simplified for us because it will always be odd. Because 3 raised to the power of anything, whatever n is going to be, is always going to be odd. So 0 plus, so we now have to test 2 cases. When n is even plus odd number will give us odd. And when n is odd plus odd will give us odd. So this one will always be odd. So that makes telling us that this one, possibility of this one being a prime, like is always going to be odd. So so now they said when m and n are natural that take on values greater than 1, which of the following 4 expressions cannot take on prime value for n? So this one can take 2 raised by m. Let's look at that again. I hope we are not making a mistake. Let's go back to the 2 raised by m. I think we made some slight mistake. So for the 2 raised by m, I think I didn't consider the case. Even I think I made a mistake here too. Okay, so let me check again. Yeah, I made a mistake. So the mistake we made for the 2 raised by m is that we didn't consider, we only consider when m is odd. We didn't consider n plus 1 before we added it. So let's do that. So we need to be very careful. So when n is odd, we have odd plus odd, because 1 is odd. So first, odd plus odd is odd. Odd times odd is odd. So we now have odd number. Odd number plus, no, odd plus, wait, what am I saying? Odd times odd is even. No, odd times odd, sorry. I'm making a lot of, odd times odd is odd, yes. Odd plus odd is even. That's where I made a mistake. So odd plus odd is even. So these two will give you even number. And this one is odd number. So odd times even number, odd times even number, odd times even number is even. So the whole of this, if n is odd, n times n plus 1 will be even, not odd. So even number plus even number will give us even. Let's check when n is even. Again, one has to be careful. It's easy to make mistake on this kind of problem. Now n is even plus odd. Let's check so that we won't make mistake. Even plus odd. Even plus odd or odd plus even is odd. So this is going to be odd. And even times odd is even, as we have said. Anyway. So we now have even plus even again. So it tells us that this option 3, will always be even. Remember, we'll go to the other option 2. So we've gotten that option 3 will always be even. And if option 3 is always even, it can never be prime. So this is a possible candidate. We've done for this before, so it's possible this is prime, it's possible this is also prime. So let's check for the last one. Remember, we did a mistake for that, so I will just try to check where the mistake was so that we can fix this. So let me clean this first. So remember, 3 raised by anything will always give you an odd number, irrespective of what the value of n is. That one is settled. Now, if n is odd, then we have here will be odd plus 1 is an odd number. Odd plus odd, just like 3 plus 3, will give you even. And odd number times even number will give you an even number. So an even number plus an odd number, just like 3 plus 4 will give you an odd number. So first we have an odd number. Now let's check when n is even. So n is even plus odd, just like 3 plus 4, 7. So even plus odd is odd. Even times odd, just like 3 times 2, 6. So it's going to be even. Even plus odd will give you odd. So we have now seen that for the second case, whatever the value of m and n is going to be, it will always be an odd number, which can possibly give us a prime. Okay? So this one too is out. So the only possible one that cannot be a prime for any value of m and n is 3. So our answer should be 3. So let's check. That answer is correct. So we got it, 3 only. So you can see how to solve this. Of course, there are many ways of solving a Olympiad question, but the best way you can understand, you try to understand from that level. You can see how they did this. They were testing, I think they were basically testing various values, and so there are more ways to solve as we go on, but we are just building foundation for now, so we just take it at the basis. So we'll come to the end of the problem solving session for a senior, the intermediate World Maths Team Championship. So I hope you guys will stay in touch for the next video where we'll be solving subsequent problems, the next problem. So I hope you guys have a nice time. See you in the next class. Please do like, subscribe, and share this video, and send it to your friends that you think want to participate in this competition. And I wish you all the best. Thank you.